Use the discriminant to predict the number and type of solutions the equation below should have. So, the discriminant is our friend in the quadratic formula that's under the radical. It's the b squared minus 4ac. So, this quadratic equation is set equal to 0 and written in standard form. So, b squared minus 4ac is telling me I have what? Negative 4 squared minus 4 times 5 times 3. Well, 16 minus 60 gives me negative 44. So when I do the quadratic formula, x equals negative b plus or minus the square root of negative 44, I'm taking the square root of a negative number. So because my discriminant is negative, it's telling me I have complex conjugate solutions. I have complex conjugate solutions. I have two of them. I have a plus bi and a minus bi. So I'm going to end up getting complex numbers as my solutions here. Number 2 says solve that equation. So it's 5x squared minus 4x plus 3 equals 0. And we know we've got a square root of negative 44. So I know my solutions are x equals negative b, the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2 times 5, which is 10. So those are my solutions, and how do I simplify this? Well, the square root of negative 44. Well, first thing I'm going to do is I'm going to take out an I. I've got a square root of a negative number. I'm going to write that as I radical 44. Well, I can split up 44 as radical 4 and radical 11, so that gives me 2 radical 11. So it's really 2I radical 11 because I've got that imaginary unit there. So we get x equals 4 plus or minus 2I radical 11. That's what the square root of negative 44 is equivalent to. We changed the way it looked, but we didn't change its value. And I'm dividing each of those pieces there by 10. So my final answers are 2/5 plus or minus I radical 11 over 5. Those are my solutions. Did I get two complex numbers? I did. I got non-real solutions there. Solve the equation here. Well, when we solve quadratic equations, we always set them equal to 0. 2x squared plus 8x plus 9 equals 0. So, I could try factoring this by asking myself, what multiplies to 18 that adds to 8? Is it 1 times 18? Is it 2 times 9? 3 times 6? I'm out of options. So, let's apply the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we've got to clean up what's inside that square root there. 64, just type in your calculator, 64 minus 4 times 2 times 9. 64 minus 4 times 2 times 9 gives me, as I'm typing this wrong into my calculator, negative 8. Yes. So negative 8 plus or minus the square root of negative 8 over 4. So how do I deal with the square root of negative 8? Well, the first thing I'm doing is I'm taking an I out of that square root, because that's just weird to have the square root of negative 8. And then I'm breaking that up as 4 and 2, so I get 2I radical 2. So x equals negative 8 over 4 plus or minus 2I radical 2 over 4. And my final answers are x equals negative 2 plus or minus the square root of 2 over 2, I'm going to put the I at the end, square root of 2 over 2, I, after I divide the top and bottom there by 2. Those are the solutions to my quadratic equation. They are complex solutions. They are non-real answers. And finally, we end with solve the equation 3x squared plus 1 equals x. Well, again, not equal to 0, so we've got to set it equal to 0. We could try factoring by saying what multiplies to 3 and adds to negative 1, but 1 and 3, negative 1 and negative 3 don't work. So we apply the quadratic formula. X equals negative b, so positive 1, plus or minus the square root of b squared minus 4ac all over 2 times 3 is 6. So we have x equals 1 plus or minus the square root of 1 minus 12 is negative 11 all over 6. Well, when you see the square root of negative 11, the first thing you better be doing is taking out an I and saying I got x equals 1 plus or minus I radical 11, can't split up 11, over 6. If you wanted these in true a plus bi form, you would say 1/6 plus or minus radical 11 over 6i. Really, either one of these two are okay, though. That's how we use